Hello everyone, welcome to my channel. Today I will show you how to blink an LED using Linux on a Raspberry Pi Zero board. If you follow the cursor, you will see me pointing at the Raspberry Pi board. This is a Raspberry Pi Zero. You can see my finger pointing to it. So my finger is also pointed to it. So this is the LED, a red LED, and I will be turning it on and off. Beside that is a digital analyzer for measuring the change in voltage level and logic changes. So on the right, top right, you will see me logged into the Raspberry Shell. If you follow the cursor, I'm on that window currently. And to the bottom left, this is Logic 2 by Salier. This reads the results from the digital analyzer for me and displays it on the screen. I'm currently using the channel 0, which is this red wire. If you look at the screen that I'm pointing to, so that's channel 0. So let's look at the code. It's quite simple. It's me turning on and off the red LED. So let's first look at the code. You will see the first line. I'm importing Raspberry Pi GPIO. So GPIO stands for General Input and Output, and it means the pin the LED is connected to can either be input or output. So I'm currently using pin 2. So I created a variable with the value 2, integer value 2. I created another variable called rest with value 0.1 because I'm trying to do something interesting. I'm trying to increase the pulse width for every cycle. The pulse width is the distance. By zooming, if you look for my cursor, the pulse width is the distance between one edge of this waveform to the end of the edge of this waveform. So my end goal is to increase it for every cycle. A cycle is when you get two waveforms on and off. That's one cycle. Goes on, off. That's one cycle. So for every cycle, there's a 0.1 second increase, and it starts with 0.1, then goes on to increase for every cycle by 0.1. I go ahead and call this function UPI.setMode to use the board numbering system. So there are two numbering systems that can be used: the board numbering system or the pin, physical pin. So one is based on the chip, or one is based on physical board numbering. I also ignore warnings. Then I set the pin to out. So the pin is going to be outputting wave form. So it's going to be outputting voltage. It's not going to be using. I'm not going to be using pin 2 for reading values. So then I create a loop, a while loop that is true, meaning it's an endless loop. The first thing I do inside the loop is to set the value to high, meaning the value goes up. Then I rest for 0.1 second. Then I go low, turn the pin off, that's pin 2 off. Then I rest for 0.1 second. So I go high for 0.1 second, then go low for 0.1 second for one cycle. Then I increase the pulse width by 0.1 second again. So, and that repeats itself. That will now be 0.2 second rest. So the pin comes on and there's a pulse width of 0.2 second, and pin goes low, there's a pulse width of 0.2 second, and it gets increased again to 0.3, and vice versa, and and etc, and goes on like that throughout the loop. I'll go ahead and show you how this works by running this Python program. Let's leave this. So first I will run my program. I've not started the program, so all values are low. Remember, I'm using channel 0. So let's start. You see the LED flickering, going on and off, and you can see the value being read in channel 0, and you can see each circle increasing as specified in the program. So let me show you the waveform. Let me show you a closer look at the waveform. Give you a closer look waveform. So yeah, so you can see the waveform. So as time goes by, each pulse width will increase, and therefore the cycle keeps increasing. So see, we started out with pulse width of around 0.1 milliseconds, and keeps 0.2 and keeps increasing, 3, then 4, keeps increasing, then keeps increasing until to infinity. So I will stop measuring. So I'll stop measuring, and so also LED has stopped flickering, so as measurements. So The end goal was to show how to flicker an LED using Raspberry Pi, using Linux on Raspberry Pi. And I hope I've passed some information, and I would like your feedback on what you learned and what you think you might want me to post next video. And my plan is to post Linux stuff all the way from cloud all the way to embedded system and kernel stuff. So see you next video.